actual code in Eclipse. And we're taking some output here. Here in the book is our selection sort algorithm. But let's jump down to the programming exercises down towards the end of the chapter. In the programming exercises, towards the end, here, one way back, just a few exercises they give us. One is to, we'll come back to the binary search part. We're going to look at 3 algorithms, problems 2, 3, and 4, which are taking methods, or writing methods called remove, remove at, and remove all. So let's take a look at my code here. Here's my GUI that I've given you. This first one, I think I gave you the code. Let's double click on that button and go down into the code. And I don't remember now, it's been so long, what code I actually gave you. But here's the code. There's my little test array, my little test data. You have most of this? Now, I don't think you had the selection sort. I think that's the part that you had to write. So basically, we have some data. We list it before we run our sort. We run the sort that we have to program ourselves. And then if it's working, I'll see the sorted array. And the selection sort is over in my sorting.java file. So I go to my sorting.java file, and I look for my selection sort, and there's the code that we looked at Friday. So let's walk through this just to make sure we understand it. This variable index is starting at 0, going to the element 1 less than the last element. And while it's looking at each element in my list, yep. Yeah, in the link to the exercise, there's a GitHub link. So every element in the list, that's what index is going through. And now inside of each time I look at element at position index, I say, okay, it's the smallest thing I found so far is at that location. And now this little loop here basically looks through the rest of the elements. See how min index is starting at index plus 1 and going all the way to the last index in the list. Min index is taking the value of all the rest of the elements, and one by one comparing is the one that I'm looking at down the line. Is it less than the smallest index? If it is, I don't do any swapping. I keep track of where it is. That's what smallest index is. It's keeping track of what is the smallest thing I found so far in the rest of the list. And then, after I've looked at all the rest of the list, if smallest index is not the same as where I currently am in my outer loop looking through everything, then I know I found something smaller. At this point is when I then exchange values in the array. This actually modifies the array. I haven't done anything to the array except keep track of where the smallest thing is until I get to here. Any questions about that? That's something we did Friday. But now what we want to do is test that this works. So, yeah.
I've imported the code from GitHub.
Yep.
But the menu on the left side isn't there.
Take a look.
Reset your perspective. There you go. Yeah, the Eclipse, you're just getting used to that Eclipse IDE. Little things go wacko on you sometimes. This is the field. Yep.
Now what I do, I'm used to switching back and forth. So when I double click on the tab, it takes me to the single view of that code. If I double tap it again, it takes me back to my perspective. But like you were saying, sometimes the perspective can get messed up, and you can go to, was it Window, Perspective, Reset Perspective. Otherwise, the first thing to try is just double tap on the tab up there at the top. Double tapping takes you single view. Double tap then takes you back to the previous perspective. Okay, so let's make sure. Well, this is then the sorting. Once that sorting selection works, what I should see is an unsorted list listed to my text area. And then after the sort is done, I will then display the sorted list. So let's run it and see if that actually happens. There's my program. I click sorting 1, and it lists my array. Oh, I should have put a new line before that. It lists the array before and after the sorting. So there's sorting 1. That's not an assignment, but we need now to just verify that our sorting, that our selection sort works. We're going to be working on insertion sort later. Okay.
Did you fix something in the code? Because mine doesn't even say that.
Let's go back and look. In my code here, here's what I need to add a new line before there. So I have that starting on a new line. So check the appends. We did create a list called list. This just generates some output. And then selection sort. Now this is in the action listener for that button, sorting 1 button. So next thing to do, check your sorting code to see, do you have the selection sort in there? Because I don't think I gave you the selection sort. So that's the code that you need to add to that. But we'll come back to that and help you with that. How about this? Let me just grab this. Copy it. And what's your email? There you are. Selection sort, cell sort. All right, there's your code. Just paste that into your selection sort. Okay, but the key thing is here now, we want to go on to the next problem, which is a different problem. Even before we start some sorting, we want to test a few routines, and back in the book they describe them. If I look back here at the book, problem 2. We'll come back to problem 1. Let's do problem 2. We need a method called remove that takes 3 parameters. An array of integers, the length of the array, and an integer, which is the item that we want to remove from the array. So let's go back to my main. Now I could decide at this point, do I want to put these in a separate class? I decided, you know, there's not that much code here. I'm just going to add this code to the bottom of JFrame main class and just add the methods down at the bottom after the main method and JFrame main constructor. I'm going to add these methods right here in the JFrame main class. So right at the bottom, here's my remove algorithm, and here's the definition of my remove. Notice the comments. Always put comments before your function describing what it does. Even put a comment on what it's a solution to. I probably should have put a Malloc Java book or something. Malloc Java 5th edition. And what we're doing here is removing an item from an array. Given an array A of integers and the current length of the array, and I'm calling it rval, is the value in the array that I want to remove. This is a new function that we're defining outside, just after. Yeah, this. Remember, this has the end of JFrame main constructor. Be very careful where you put these methods. Right before the very last piece of code, end of class. Your methods go after the constructor. Give yourself a lot of white space, knowing this is the end of my main constructor. No. We want to make a separate method that we can call from when we click the button. We want to make this method completely independent of being inside that button action, because we want to be able to call it from somewhere else if we want to test it. So define this outside of the main constructor. There's the end of the main constructor. This remove function takes an array A given its length. Now let's walk through the proposed solution and see if it makes any sense here. Here's my proposed solution. Now it's up to you to see whether this should work. So what do we have there? We're declaring the array A, array of integers, and deciding that found, this Boolean variable called found, is false at the start. And I assign some variable I to be 0 at the start. Now let's look at that while loop. What's going on in that while loop? Well, not found, and I is less than len, which is supposed to be the length of my array. What in the world is that? Found equals rval equals a I plus plus. When you're looking for answers and you go to Stack Overflow, some smart guy will give you an answer like that. And you stare at that thinking, how in the world is that the answer to the problem? Now, you might have not written the code this way, but as people start writing code, they get tired of writing multiple lines of code. And we're doing multiple things on that one line. Yeah.
I think if the value found equals the value rval, then it is the index of my array and assign that value to it.
Pretty good. Close. Think of, first of all, found is a Boolean. So found is can only be assigned something that's true or false. So this is a comparison. This is a logical comparison because I have a double equal there. So the way to think about this is rval, if rval is equal to what I see at position I, then found equals true. And because this guy didn't want to write a separate line of code, basically this is equivalent to saying, oh, after doing that check, increment I by 1. Remember, the plus plus to the right means I gets read and then incremented. So it's a post increment, meaning since I care what's in I, but next time around I want to see what's in the next value of I, I'm incrementing I after finding a sub I. So I'm comparing our value to what's at I, incrementing I after doing that, and if found is true, look what the loop will do. Oh, if found is true now, I'm stopping the loop. So this loop has two ways of stopping. Either I gets too big to the equal to length and then I'll stop, or I happen to have found a value in the array that matches what I'm being asked to remove. So when I'm outside this loop, if this loop is done, either it's been found, rval is found, or at the end of the array. When I finally got to here. And I will be one past where I just found it if I happen to have found it. Because remember, after checking, I increment I no matter what. So, now if I found it, what do I have to do now? And this is what you have to think through the code now. And this is where I'll draw a picture. And pictures aren't so easy to draw in code, although sometimes you'll see people do that with goofy ASCII characters. Think about this now. If I have an array, and say I'm going to remove, say there's a 2 there, and the R value is equal to 2, well, index, let's see, the value of I is going to be 0, 1, 2. Oh, I found it here where A sub 2 equals 2 is true. At this point, I has been post incremented, so I is equal to 3, but the element I'm looking for, I want to remove it, is 2. Is at position 2. How do you remove element 2 from the array? How do I remove element 2? Say I have an array, so many elements, and that's the one that I want to remove from the array. Yeah, that's the way I do it. But this author of the malloc book, he likes to do it a different way. He likes to, instead of recreating a new array all the time, he just changes the length and says, okay, length is less than 1, and I have to shift over all these values. Right.
The next element to it.
And that's how the author wants us to do it. I like the way of just, here's the array, make a new array, and initialize it with 1 less, and fill it in. But another way to do it is say we're going to, instead of reallocating arrays all the time, that's the whole point of is having that separate length variable. Because think, why do I need a separate length variable? Arrays know how long they are. Well, so we don't have to continue to reallocate arrays. We're using a separate, here's how many elements are actually valid in my array. Yeah.
I think we can start an if statement, and once that true statement is true, we can take that element, and whatever comes next, or the statement that comes next, is moving the rest of the element.
And that's what that loop is doing. If found, while I is less than length, okay, remember now, I is now here when I'm done. When I found it, I is pointing to here. This is value I equals 4. Do that.
But yeah, because if we implemented the index from there.
Yeah, I is pointing to this one because every time through that first loop, I is getting incremented. So here's where I is. And now I say, okay, let's point J to be I minus 1, which is where the value that I want to remove is. So let's see what's going on now for the rest of the code. Keep going to the rest of the array while I is less than length. Put what's in position J into what's in position I. So I and J are basically following each other, and that's essentially shifting over all the way to the end of the array, basically replacing his value with what's here, and then replacing that with what's there. So basically shifting, I call that shifting the entire rest of the array 1 to the left. And that's what that little loop there is doing. So I should probably put comments in there. See how J and I are just getting incremented 1 by 1. Again, the shorthand way, find the value at J, and for the next time J will be 1 more. The post increment of J.
How does it want to remove the specific number in the array or specific spot?
Well, remember, we have found and stopped this loop up here as soon as we found a value that matches our val. So I has been incremented one past where I found the value. So if I found, I'll put a little comment here, I is pointing to, or I'll call it the value, the position of the element to one to the right of the value that we want to remove. J, because it's J is I minus 1, J is at the position of the value I want to remove. So this loop right here goes, this loop, this tiny little loop right here, for I going to the end less than the length of the entire array, I am putting at position J, what is at position I? And then incrementing both J and I all the way to the end of the array, essentially shifting over the rest of the array. And this is very important. Because I'm removing one element from the array, the length that I return is one less than the original length of the array. So, back at the calling program, back in JFrame main, here where I'm testing the code, where is the test for the code? Up here, now we have to look at the actual testing of the code. Here is the testing code. And this is the part, now that we think we have remove working, now we have to figure out how to test. Is that remove method working? So here I generate a test array. And I don't think I've given you this code, so you can add this code to the code that does the problem exercise 14-2. So just double clicking on that button should take you to the action performed for that button. Here is the testing code. I'm not doing the testing code inside the sorting.java. The testing code is in my main program. So I generate an array of numbers. I list it out in that text area because I want to see what it is before I start running. I now remove, in this case, I'm just for fun removing element whose value is number 4. And then let's see what I have after I'm done. So the testing is list what's in the array. Oh, and I'm returning a new length. Remember how that returns a value of how long the array is? If it hasn't been removed, the value of length will stay the same as it was before, and that's what this is about. If the length of the array is the same as what I gave it, then I know I didn't find that element, and I should get I'm going to append a message to that same text area. Oh, I didn't find the item. I probably should have put item 4 not found, since that's the one I was removing in this little particular test. This would be in the exercise 14-2 button handler, because that's the one that we want to test. So double clicking that button takes you to your event handler, and that's where you need to put this code. Okay, yep. And that's why in comments here, see how I have the button. It usually, since I did put a label on that button, I can tell that's where I am. And it wouldn't hurt to actually put in the comments here testing portion of problem 14-2. The remove method that I wrote, that's the first part of 14-2. This is the part where I actually test it. So even though the testing part in this case is pretty easy, I make a test array right here in memory, and I call remove using that test array. Hard coding, oh, let's try removing element number 4. I know the result should be, if it's working, I should get an array with a new length of 1, and it should be 1, 2, 3, 5, 6, 7. So there's the testing code of the remove method. Now, if I didn't want to generate all that output, I could just do create a test array, call remove, and then run it in the debugger and put breakpoints everywhere and watch to see what my array was after this line was over. So the debugger is very handy if I don't want to go through and write a whole piece of testing code. But we want to practice being that code tester, writing the code around, here's one routine, one method that I'm wanting to test. And if this were really a full test, I would be reading gobs of data, feeding it lots more than just a boring 7 array. I would create huge arrays and try to maybe even see how long this took, just to see, does my processor, is it taking as long as I expected? You could do all sorts of testing, even on a simple algorithm like this. So we did the remove part. Here is the testing portion. So fairly easy, not a whole lot of new coding logic to learn. It's more of, let's do our proper procedure. We've written the code. Let's test it with some test data. With reasonable output to the user that's running this program, I see what was in the array before and after I ran the test. So if I run this, I should see something like this. Exercise 14.2. Here's the array before. I have a little message after removing 4. Yes, indeed, I do get those elements in the array. All generated by these few lines of code. Notice here, this loop here, I'm going to the new length of the array that got returned to me. As the malloc likes to use arrays, keeping a separate number of how many valid elements are actually being used in the array. If I were writing this code, I would simply recreate an array of a new length. But that does take a lot of extra memory, and that's why most people, after using arrays like this, they will go to array list. Array list code actually handles all that allocation for you. Any questions about this particular testing code? That's what would go in your 14-2 test, or solution, sorry. So I'll give you a little time to get that tested, and then I'll go on to the next one. You'll find the next one even easier. Once you've done this, it's like, oh yeah, 14-3. It's just a matter of figuring out that remove at. Most of this I can copy paste into my remove test for that other button. The only thing I'm going to change is the method call is going to be remove at instead of a remove. But let's make sure you can get this code working. I'll come around and help you with any typos. I'll leave this up on the screen. Anyone having any trouble with that? I can come and help you. I want to make sure you... My son's having car trouble this morning. Sorry, can't talk. Gotta turn that volume off. The reason I have that is there's another teacher at Emmaus that has that as his ringtone. And so if I ever forget to turn down my sound, they'll think it's him. Because he's well known for that ringtone. Stockfish. So if I ever have that happen, I'll just look over at Stockfish and smile. Hey, there you go again, Doc. So let's get this tested, and then we'll go on to the next one. I don't want to leave any confusion. give you time here because, and then Wednesday we'll be able to get the next two done. How's it going, Brandon? You run it and you get the results. Excellent. Okay, well, while you're waiting, try to write the remove at method. Take your remove and see if you can do a remove at. You could almost start with remove and just modify to make a remove at. Very similar to remove. That's going over here. Okay? All right. Now after that, the only thing let's see the bottom of that. I think that's the only thing that happens. I don't think there's anything after. Yeah. The function is done at this point. So that's the end of this action handler. Sorry. Yeah. Yeah. So if you go to the bottom where you have remove, you just make a copy of remove and change it to remove at, and then it's just a slight modification in the remove function. Because instead of stopping when we find the rval, we can jump right to the position that we want to remove the value at. So the remove at is actually a lot easier than to remove a particular item. Because we're not even doing a search. We've been told where to remove something. So we don't even have to look for it. So there's the test, and then the actual remove at, sorry, the remove is down here. Right here. Here's our remove. And it returns either a shortened array, because I've found it. If I have not found it, I just return the original length of the array, because it wasn't there. And then the calling program can generate the error message. So this is a case where I don't want to, as much as possible, I do not want to generate error messages from utility functions. Just the name of the function, really. Here's remove. Again, if I haven't found it, if I haven't, this is basically, I should put a comment here. Search for the item to remove. So search for rval. This line right here, study that. Make sure that makes sense to you. What am I doing? I'm doing three things there. I'm comparing rval to what's at position A sub I. If I get a true, found gets assigned to a new value true. Otherwise, found stays false. And at the same time, I'm then incrementing on. So rather than have a separate line that says I plus equals 1 or I plus plus semicolon, I just throw in the I plus plus right there just to be more economical in my code. And the reason I put that is not only to show you that's a shortcut, but you may have to read someone else's code that does this, and I don't want you to be confused. There's plenty of other things that they will do like this that will be confusing as you learn coding. And very valuable to read someone else's code. You learn lots of things. You come to a line like this and say, yeah, I kind of like doing it that way. And then now you've learned something. You might come across people that write very annoying, very hard to read code. You realize, I'm not going to write it that way because no one else is going to be able to read this. But this is common enough that I threw it in there. If I only need to get at J once, I'll increment it right while I'm there, rather than think later to add a separate line. Same thing here. Rather than have to write multiple lines, I know that I just care about looking at the current value of I, incrementing it all the way through to the end. Ready to look at remove at? I think we have time. We've got 2 minutes. We'll just take a quick peek at remove at. And the thing is, if you watch the video, you'll have the whole thing there and you're ready to do it. Where's the remove at? Remove. Where did my remove at go? Oh, there's my remove at. Look how short that code is. It's actually shorter than the remove because all I care about is, oh, I found a particular location. Here's my array. quick draw a picture. Here's my array. And I've been told to remove that item. I've been given the position of the item. So what do? I simply say, to remove it, I go up to that position, leave everything alone in front of that. That value goes there. That value goes there. That value goes there. That value goes there. And I return length minus 1. The original length minus 1. Until I get to the end of the list. So this is the item I want to remove. I jump right over to there. So we see that our location right away. I set I as our location. And see how I goes to 1. This is where I put I. And I goes all the way to here. The value of I goes from there to there. And I simply say, the thing that goes into position I is equal to, what's that position? I plus 1. So this is the segment A sub I is equal to A sub I plus 1. That's what that arrow means. I'm taking what's in that value, what the value is there, putting it where I am here. So this is at position I, this is at position I plus 1, all the way until I gets to here. So I'm basically, like I have in my comment, shift the array 1 to the left. Remove at, really easy method. But still, we need to test it, right? We write the code, and then we test it. So to test the code, go back to my design of my J-frame. Look at the code on 14-3. It's almost the same array and almost the same code listing the array before and after. The only thing that's different is that right there. I changed remove to remove add. So the testing code, because remove add is so different, or so similar, it takes the same 3 parameters. Instead of the value, it's the position thing at position 4. And if I look at this array, 0, 1, 2, 3, 4. The 5 should be gone if I'm properly removing the item at index number 4. Well, if we run the code, let's see what happens. 14.3, there's my array, 1, 2, 3, 4, 5, 7, 8, 9. 1, 2, 3, 4, 7, 8, 9. Yes, it looks like it did remove the item at position 4. See how quickly that was done. And because we had done code already, it's copy and paste the previous test code, run them, remove that. See how easy the testing is getting? Now we can think about even more interesting data. At least we've tested the basic functionality of remove at.
Can you go to the design window and hit on
14-2. There's my remove test. I generate an array. I list the array there. Here I call the remove. And then I list the array again. And this here, just is because there's so many ending parentheses that start getting in my way, feel free to add your comments end of if statements. And of course, white space helps to see where your code is starting and ending when you have these little curly braces. It's easy to get confused of where your curly braces are ending. So we've got 2 problems solved right now. The remove at, and the testing of it. And of course, feel free, if you go back to the testing, after copying and pasting the same test data, you could maybe make this array a little more interesting and decide to remove something at another location. But for now, we're happy to test it with 1 instance of the array, remove 1 thing, and see if we get the expected result. If you don't get this big expected result, you can run through the debugger and find, okay, where am I getting it wrong? I know what the answer should be if I remove item 4. All right, so Wednesday will be look in more detail at those remaining problems, see how far we can get at writing the code for testing and confirming the rest of the problems.